So the topic for the video lecture is modular programming. And what is modular programming? The task is divided into subtasks. Separate modules are written for performing these subtasks. Each module is tested separately. The common routines required in modules are written as separate module and they are called from individual modules whenever required. Programming done in this fashion is called modular programming. So what are the advantages of modular programming? So code is short, simple and easy to understand. It is easier to design, test and debug a single module as compared to an entire program. The scoping of variables can easily be controlled, documentation can be easily understood. So whenever you need to retype the codes, that can be avoided as the frequently used modules are stored in the libraries and these are used by several programs. And it is easier to do modifications, if any, in a single module rather than in a program. What are assembly language components? We have four classifications over here: linking and relocation, structures, procedures or subroutines, macros. Execution steps of a program. So this is the first structure where we have three blocks, which is translator, linker, loader. These are all software. So where this translator translate the program, and the linker does two functions. One is the linking of a program with other programs which is needed for execution. The other function is relocating the program in a specific memory such that it is easy for the execution. And the third one is loader, which will load the program in the memory for the purpose of execution. So these are the execution steps of a program. And this structure or this diagram shows how the assembly language program is created and executed. So you could see a source module, and the source module is given to an assembler or any translator where this will be converted into object modules. So the object modules are listed, and this along with the library functions, it is given to the linker, and the linker will convert this object module into the load module, and certain modules can be even relocated by means of the or in a particular memory allocation, which we put as a memory map here. And this load module, once it is loaded in the loader, it will be converted into a executing program. So this executing program or these modules get executed depending upon the commands given with the help of the IO devices, or it drives the IO devices. So the second one is, the second concept is segment combination. So in addition to all the linker commands, the assembler provides a means of regulating the way how the segments are in the different object modules and how it is organized by the linker. So we have a common syntax, which is segment name, segment, combination type. So the combined type or the combination type indicates how the segment is to be located within the load module. So the segments may have different names, and certain segments may have the common names. The segments which has the common names can be combined, and the segments with the same name but we don't have any combined type will cause a linker error. And these are the combined types. We have 5 combined types, which is public, common, stack, add and memory. Public is like if the segments in different modules have the same name and we have the combined type to be public, they are concatenated into a single element in the load module, and the ordering of concatenation is specified by the linker command. And coming to the second combined type, which is common, if the segments in different object modules have the same name and the combined type is common, then these will be overlaid so that they have the same starting address, and the length of the common segment is that of the longest segment being overlaid. And coming to the third combined type, which is the stack. If segments in different object modules have the same name, and the combined type is stack, then they become one segment whose length is the sum of the lengths of the individual specified segments. In effect, they are combined to form one large stack. And the fourth type is AT combined type. It is normally followed by an expression which will evaluate a constant, and this constant will generally specify the segment address. So the advantage of this one is it will allow the user to specify the exact location of the segment in the memory. And coming to the fourth type, which is the memory. So here the combined type causes the segment to be placed at the last of the load module, and if more than one segment with the memory combined type is being linked, only the first one will be treated as the memory combined type, but the others will be overlaid as if they had been a common combined type. And this is an example of segment combination with the combined types to be public and common. And here you could see two source modules. Each module has two segments. One is data segment, the other one is a code segment. And the data segment represented in both the source modules are common, and the code segment represented in both the segments are public. So we have the same name and the combined type to be common and public. So once it is public, so which is the code segment, it is that is concatenated, and once if it is the common, then it is overlaid in the sense, so the data segment in the source module 1 will be of some size, and the data segment in the second module will be of some size, and this is overlaid such that the length of the segment is depends upon the length of the biggest segment. And we have the other structure of the program as procedure. So procedures are normally the group of instructions. They are stored as a separate program in the memory, and it is normally called from the main program. So the type of procedure depends where the procedure is stored in the memory. So we have two types of procedure. One is near procedure, other one is far procedure. If it is in the same code segment, then we call it as a near procedure, else we call it as a far procedure. And still we have two more categories, which is reentrant procedure and the recursive procedure. So reentrant procedure is nothing but procedure 1 will be called from the main program, procedure 2 is called from the procedure 1, and again procedure 1 is called from the procedure 2. So we have the execution flow, or there will be a re-entering from one procedure to the other procedure. So these type of procedures we call it as a re-entrant procedures. And recursive procedure is nothing but when a procedure calls another procedure within itself, we call it as a recursive procedure. And we have the fourth structure as a macros. So macros are group of instructions, and whenever the macro assembler calls a macro, it will generate the code which is written for the particular macro segment. So macros can be defined by a name with the macro, and definitely there should be a statement with an end of macro. And here you could see an example which is init macro, and we have certain statements under it. So whenever a macro is written in a program, these set of statements will be substituted over there, or these code will be generated every time the macro is written in the main program. So what is the comparison of procedure and macro? So as we know, the first comparison is procedure can be accessed by call and return instruction during the program execution, and the macro is accessed during the assembly with a name given to the macro when it is defined. And the second comparison is machine code for the instructions is put only once in the memory, whereas in the macro, so whenever the macro is defined, this set of machine code is generated every time the macro is called. And the third comparison is obviously the procedure will be requiring less memory, whereas the macro will be requiring more memory. And the fourth comparison is the parameters can be passed in registers, memory locations, or stack in case of procedure, whereas in the macro, it is passed as a part of a statement which will call the macro. Thank you.